Hey guys, we're going to be doing some energy problems, and so I'm not doing the embedded webcam this time because I have this in tablet mode on my table, and so all you'll be seeing is my ceiling, and that kind of feels funny. So first, I just kind of want to show you the old pacing guide from March 2nd before we enter this strange time. There is a video called Energy Concepts that will help you immensely with these factor label problems that we're going to start today. And it's a Bozeman video. So even if you've kind of given up on the videos, which I know a lot of you have, and I'm not blaming you, that video specifically would help you quite a bit. So we're going to work through 3 problems from lecture. This is number 10, 11, and 12 on your reading guide. So what you might notice, if you look on the back of your reading guide, is kind of some conversions that we're going to give you. Okay, so 1 megawatt is 1 million watts. Mega means there's 6 zeros after it. A megawatt is 1,000 kilowatts, and so on and so forth. So we're talking about units of energy here. Okay, and so when you learn in chemistry factor label, you were probably doing stoichiometry. We're applying this to energy, and this could easily show up in an FRQ. They haven't done it in maybe like 3 years, and you will have an FRQ on this next week, I believe, Monday. So let's work a few together, okay? So the capacity of a wind turbine is 3 megawatts per year. How many kilowatts can be generated in a year? So the conversion that we're kind of looking at, my pen working? Let's do, okay, first of all, let's go back. Let's do not red. That's fine, whatever. So we're looking at 1 megawatt is 1,000 kilowatts, and that's given to you. And so remember, when you set up factor label, or I think Mr. Anderson calls it dimensional analysis, you want items to cancel. You want units to cancel. So we're starting off with this 3 megawatts, which means that we have to put megawatts on the bottom over here. Okay, so 1 megawatt is equal to 1,000 kilowatts. Our megawatts are going to cancel. You could have this over 1 if that helps you. And then remember, you get to use calculators this year, so that's good. Then you just multiply across the top and multiply across the bottom. These are the units that we're going for. 3 times 1,000 is 3,000. 1 times 1 is 1. So our answer here is pretty simple. It's 3,000 kilowatts. Now you should be prepared to recognize and perhaps write in scientific notation as well. So I'm going to write or. Remember, scientific notation is going to be an item in the like the ones column, perhaps a decimal, times 10 to the whatever. So this is how I do it. 1, 2, 3. So this is 3 times 10 to the third kilowatts. So that would be my answer. Okay, let's try a harder one. I kind of want to change my ink color. Purple? Pen. Oh, geez, but now I need my arrow. Okay. A capacity of a solar plant is 30 megawatts. Assuming the power plant can operate at full capacity for 6,000 hours a year, how many kilowatt hours? Now, that's also a unit of measuring energy that the power plant actually uses. It's not kilowatts per hour, it's kilowatt hours. So they're all going to be in the numerator. So how many kilowatt hours of electricity can be produced by the plant in 1 year? So I'm going to start out with my 30 megawatts again. It does write in purple. That makes me happy. I like to put it over 1 just as a visual. I know that my megawatts have to go in the bottom over here so that they will cancel. So I'm going to put my 1 there. I know from the top of my sheet that there are 1,000 kilowatts in 1 megawatt. So I'm going to put my 1,000 kilowatts on top. And I know I have to somehow get hours there too. And we're talking about kilowatt hours per year. So we've got 6,000 hours per 1 year that it's operating. And so our megawatts are going to cancel. That leaves kilowatt hours per year. Multiply across the top, multiply across the bottom. And we're going to get a pretty big number. We're going to get Oh, there should be no comma there. I don't know how to erase. We're going to get 180 million kilowatt hours per year. Now I want you to pause this and see if you can convert that to scientific notation. So pause. Okay, hopefully we're back. Remember that if a question's asking for a number, you usually have the liberty of giving it in standard notation like this or in scientific notation. A lot of calculators will do either for you as well, but they'll often accept both. So I'm going to put or 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. That's the sloppiest thing ever, but I think I got it right. So it's going to be 1.8 times 10 to the 8th, and then my units are the same, kilowatt hours per year. Okay? So that added that extra step of looking at changing it to kilowatt hours as well. These are very common problems. Now let's take into account money. Okay, money, because oftentimes you're looking at how much energy is provided and is it cost saving to use like a windmill versus natural gas or something like that. Okay, so arrow, I advance it. Let's change my color to green. Change to a pen. All right. The city of Fremont consumes 100,000 megawatt hours of electricity per year. There are approximately 10,000 homes in Fremont. Fremont's electricity company charges 10 cents per kilowatt hour. Okay, so we're going to have to somehow take the megawatts and make them kilowatts, assuming they split it equally, because that's the only way you can do this. How much would each home have to pay? So let's start with what we know, okay? Because I know this is the jump to the problem where a lot of you are like, Simek, I don't know what to do. So we've got 100,000 megawatt hours. I write it like that. I know that the problem just has it as H. Per how many homes? Yep, 10,000 homes. So if you want to do the math right away, which I did, that's 10 megawatt hours per home over 1, which I know is kind of weird. Multiply that by the 1,000 kilowatt hours, 1 megawatt hour, which would cancel this and cancel this, gives us 10,000 kilowatt hours per 1 home times 10 cents for every kilowatt hour. Cancel that. Is ultimately going to give you $1,000 per home for that year. So the reason I kind of did it this way, I'm actually not like inherently very good at factor label at all. My brain doesn't really work that way. This is much more likely what I would do. Like, oh, I can simplify this. Now I need to multiply by 1,000. Now I need to multiply by 10 cents or 10% or 0.1. You don't have to do factor label if your brain can do it another way. It just helps when there's a lot of steps. Okay? So that's kind of the 3 on the reading guide. You will have, your next step is to do some problems on a sheet that's linked to the agenda, like a worksheet. And I know that Mrs. Stroik and I will be hosting kind of like open office hours during the week because we get that this is challenging for some of you. So good luck on the math. You guys did great. Now I have to figure out how to untablet this and like stop my video. This card, go back here.